I hope we can fill the front chairs. A lot of seats empty in the front. So I'm sure there is few people coming, so I'm still waiting. Well, I start and make the introduction a little long. Hopefully we capture a few more people. It really gives me a great pleasure and privilege to introduce Roland to this seminar. As I just said to him, I really don't know where to start from. As most of you know, Roland really have a very bright and long career, and he's one of the longest people who really served IRRI since 1984. Roland got his PhD in marine science, which is quite interesting. I didn't know how marine science and soil science come together, but that's a very interesting combination. And then after that, he joined the International Fertilizer Management Center in Alabama for some time. In 1984, he moved to IRRI and stayed here as a visiting scientist until 1991, so about 8 years, 7 years. And then after that, he joined IRRI from 92 to 2000. And then in 2000, he joined IRRI first as a senior soil scientist until 2009, and then he became a principal scientist in 2010 and retired formally, as most of you know, last year in August 2016, but he decided to stay on. Actually, we want him to stay on and still want him to stay on for another year as a consultant until 2017. So he'll be here until August of this year, but I'm sure that we'll still be calling on him to come back and help in some areas. Roland has, as I said, has a very accomplished career. He published quite a bit. He published more than 125 articles in international peer-reviewed journals and about 12 book chapters. He also, as I know, because we came here in the same year, just a few months apart, I think, he has been an editor in quite a few journals. I contributed to some of those. One of them I remember is Agronomy Journal. He really contributed a lot to IRRI science, especially crop and natural resource management. Has been a leader of some programs early on in Irrigated Rice Research Consortium, and then Rainfed Lowland Research Consortium, when I started interacting with him quite a bit. If you remember, he's one who comes, most of the creative ideas now are really being implemented in crop and natural resource management. Just a few of them is the SSNM, the soil site-specific nutrient management, and then he came with the leaf color chart to really implement it in rice, and then after that he started working on innovative aspects. How can we use ICT in agriculture and also in our extension? And if you remember, all of you probably are exposed already to the nutrient manager, which is later evolved into the rice crop manager, which is really now applied in many countries. Besides that, Roland has a lot of awards to his side. I just mentioned a few of them because it's really quite prestigious. One of them is he became Fellow of the Society of Agronomy in 2000, and then Fellow of the Soil Science Society of America in 2001. In 2007, he became the International Soil, he got the International Soil Science Award. And then in 2009, he received the CGIAR Science Award for Outstanding Scientific Article. And this is actually quite high recognition also. He is a recipient of the Medal of Science and Technology Development, Minister of Agriculture in Vietnam. This is in 2010. And then the International Fertilizer Industry Association, IFA, Norman Borlaug Award for Excellence in Crop Nutrition Research in 2011. He also received the Guangdong Province International Friendship Award in 2012 and another award in the same year with the International Service in Agronomy Award for the American Society of Agronomy, also in 2012. And probably most of you know that last year he's also the recipient of the People's Republic of China Friendship Award. This is a very high-level award in China. So as you can see, Roland really accomplished a lot and also recognized quite well in the international arena. I'm one of the who's really proud of working with you, Roland, as a teacher, as a mentor, and also as a publisher in this field. It's a great pleasure to introduce this seminar. This is not his ISIS seminar. He gave his ISIS seminar last year. This is actually his additional accomplishment seminar. You can call it his consultancy seminar, probably. So thanks, Roland, and the floor is yours.
I would like today to share with you some of my experiences in the process of taking research results to farms. Okay. So, that sounds better. So, as you know, there's really an expectation within IRRI that the results of IRRI's research really lead to large-scale benefits in rice farming. And this seminar is really going to particularly focus on the area of crop and resource management, not on the seed side. And within crop and resource management, we really recognize that one of the challenges is the knowledge intensity of these technologies. It can often lead to challenges in their dissemination. At the same time, we recognize that within an organization, there's a need to do high-quality research and publication, have technologies generated that will get out to farmers, and have that large-scale uptake of the technology. And as you heard 2 weeks ago with Noel Mager's seminar, the Institute is really looking at ways to divide up these responsibilities with impact acceleration. I'm going to use in this seminar really site-specific nutrient management as an example of the research to dissemination process. Site-specific nutrient management really goes back to about 1995 to 1999 in a very innovative stage that was led by Achim Doberman. And in 2004, the book that's shown here was edited by Achim, by Kristen Witt, and David Dahl. And that put together really outstanding, excellent science. I arrived in January of 2000, and from that time, we really had the challenge of how to get this outstanding science into a form that can reach many farmers. One of the really starting points that really is instilled in my mind is a meeting that took place in February of 2000. This was a meeting for the formation of the Irrigated Rice Research Consortium, in which there were two supporters of site-specific nutrient management. One was SDC, the Swiss, and the other was an association of the fertilizer industry. That delegation was led by Ernst Mutter, and here's Carmen Torres from SDC. And it was the most fascinating 2 days of discussion with Dr. Cantrell, the DG at the time, sitting in on some of the discussions. And IRRI scientists would be saying something like, IRRI is a research organization. And the supporters saying, technologies that we have supported must reach and benefit farmers. And IRRI saying, well, IRRI does not do dissemination. It was a fascinating, sincere exchange that has been really ingrained in my mind ever since that day. And that type of discussion and debate continues. This is what SSNM looked like in the book that Achim wrote in 2000. The challenge was to take this, which is some formidable quality science, into a format that could give farmers a practice. So now, how do we take this excellent science into a technology that can reach many farmers fast? One of the first principles we identified and we focused on was aiming for an achievable outcome that will be attractive to farmers. This is really a big lesson. Aim for the outcome. What should be achieved? And with that, right from the beginning, building upon what Achim Doberman and others started, was the recognition to increase the income of farmers. And what Achim and others had done was, through the science up to that date, achieved about a $50 per hectare per crop increase in income. And what we recognized through a series of discussions and planning was that if we fine-tuned the timing of nitrogen, and we did a better job in matching the phosphorus and potassium rates to the needs of the crop, we could probably get that to $100. And $100 per hectare with a crop became the target. And that is really what has been moving us forward. Now, the second real principle is to provide farmers with actionable, easy-to-use farming advice. It's something like apply X amount of fertilizer at Y, or X amount of the source of fertilizer in Y amount on a particular date. It needs to be in that type of form with a minimal risk to farmers and really not an added cost, particularly on the side of labor to the farmers. And the third thing was really to define pathway to end users or farmers. And right away from the beginning, we recognized that it was not going to be a technology that was going to go directly to the farmer that we would be interacting with, but through intermediaries, through extension services, and particularly through the private sector extension. Or pardon me, through the public sector extension, through the public sector and through the national system. Now I start with the first case study that is in Guangdong province of China that started with a September 2002 visit in which I had the opportunity to work with two of the brightest scientists that I've met in my career. One you know is Xiaobing Peng, who has spent time here at IRRI, and the other is Shua Zheng, who was a scientist at Guangdong province. He had worked with John Shi before at IRRI, and had worked with Xiaobing after that. We visited the field, and this was, to my knowledge, the first set of experiments that were a collaboration with IRRI and the academy at that time. And we saw this in the farmer's field. We saw an over-fertilization in the farmer's practice. For me, as a soil scientist, what I think of is the nitrogen response curve. I think of increasing rates of nitrogen and the yield increase, and then going to a point of maximum yield, and then a diminishing return with excess as there are more diseases, more lodging, more problems with the crop. And what was taking place was an over-application of fertilizer beyond the point of optimal. Now, as a scientist, the first thing that we could say is, well, it's very simple. You just lose the principles of economics, and there is a point of maximum benefit that's just before the highest yield. And one can say, just use the optimal nitrogen rate, which means reduce the fertilizer. When you think of the economics of that, that's probably going to translate into maybe $10 to $20, depending on the subsidies. It's not going to even come anywhere close to meeting our $100 per hectare per crop. It simply is not something that's going to be attractive to farmers. So the other way of approaching this is to aim for a technology that can require less nitrogen and get the same yield. That could be something like improving the timing of nitrogen fertilizer. It may be changing the source of fertilizer. People have given their whole careers and lives doing this. And what it means is that you get the same yield with less fertilizer. Now, when you work out the economics on this, it still doesn't come to $100. And there's a certain amount of risk, because if you get the nitrogen rates wrong, you lose yield. So what we really needed to do was, and pardon me, before I go on, I can say that we did show that this was achievable right away in 2002. Even though it was not sufficient, we could see that we could use less nitrogen and get the same yield. This is with a SPAD meter or a chlorophyll meter. What we needed to do was really take an alternative approach. An approach where we aim for the green line. That is, to develop a technology that will get higher yield with less nitrogen. So we're looking at this. Higher yield with same or less nitrogen. That requires really an innovative scientific breakthrough. Now, what we then went on to conceptualize and work on was this concept of a healthy canopy. That what we saw in the field was an unhealthy canopy, excess tillering, excess vegetative growth. Work on a healthy canopy that will hopefully reduce the disease and insect pressures as a way of providing benefits to the farmer, but it needs a management practice to go with it. Now, when Xiaobing and Dr. Zong looked at this, what they saw as a physiologist was this. They saw that what they were trying to do was to optimize leaf area index. So there's an optimal leaf area index for a given crop growth stage. And they could see that if that leaf area index was exceeded, there would be lodging, disease, insect problems, higher respiration. If it was not achieved, there would be lower yield. There's an optimal leaf area index for a crop canopy. SSNM was conceptualized as a tool that could help you move in either direction to get to that optimal leaf area index. And with achievement of that optimal leaf area index could be the opportunity then for higher nitrogen fertilizer efficiency with lower pest and disease pressure. And the rest really then went over about a 5-year period to a technology that was called is still called the 3 controls technology. The first part is to control the rate of nitrogen fertilizer. And in addition to that, put in the specific practices of how much, of what source, on what date. And it involved a distribution of the nitrogen with less burning and more distribution as the crop needed it. That resulted in less excessive growth of tillers, less excessive vegetative growth at the early stages, and has less disease, insect pressures, and less application of chemicals. The increase in yield was about 8 to 10%. And that was sufficient to meet the criteria for the amount of income that would be needed to be attractive to the farmers. Now, that 3 controls is an example of a blanket recommendation that can benefit large numbers of farmers that have a relatively homogeneous problem of excess fertilizer use. It was recommended in 2008 by the province, 2012 by the National Ministry of Agriculture, and it's now widely recognized, widely taken up, recognized as one of the premier technologies for fertilizer management. Interestingly, we tried in 2009 to develop a mobile phone or an ICT. Before mobile phones, it was just more on computers, tool for this. It never took off, never was used by extension. And it's really part of the lesson. In this case, when you have more of a blanket recommendation, these tools are probably not appropriate. It was really more about the personal contact that the partners had with the extension workers. So you have the research, the technology, the dissemination pathway. In that technology, we can see that really it's critical that it's actionable, relatively simple, and it benefits farmers with minimal risk. The 3 controls met those criteria. It took a local champion with passion, determination, and an ability to connect with farmers extension. The real hero, the person who made it happen, who worked long hours, perseverance, was Dr. Zong. As part of this, and as part of that success, was the integration of this into the extension service. The budget and the extension system, it was all integrated into that budget and activity of the extension system. It's not an add-on, it's an integral part of the activities of extension. It's a lesson that relatively homogeneous blanket recommendations can work in certain situations, and they don't necessarily have to have an ICT tool to be successful. The challenge there is what comes next. When you have a successful technology like 3 controls, you now must build upon it to come up with add-ons, and upgrading is essential. So hence, science must get even more innovative and creative. And it really calls for strategic science and thinking. Interestingly, there were 6 different organizations at that time in the early 2000s that we worked with in China. The They all got the same information on SSNM. They all sat in the same meetings. They were successful in varying degrees in terms of their reaching farmers. None of them achieved the same impact in reaching farmers as Dr. Zong at Guangdong Academy of Agriculture and Sciences. Why is that? I would really like to see someone in China do a case study on this. It relates to the robustness of the way the technologies were put together for the different locations. It's associated with the approach and skills of the partners. And it's also about the mandate of the partner institutions. The Academy in Guangdong is a provincially funded organization, so it has much more mandate than universities in terms of reaching farmers with technology. Now I shift to the Philippines, a different situation. Now, a situation where we're looking at very heterogeneous landscapes, very different ways of producing rice in short distance. There are big differences amongst farmers in terms of their yields, the varieties they use, the way they manage the residues, the crop rotations, the fertilization, even the soils. What this means is that one recommendation may not fit all, like we were fortunate in China. A more precise field-specific approach is then identified as the way to move forward in the Philippines. It was about 2007, probably on one of my walks to IRRI in the morning, when I realized that with SSNM, if I could interview a farmer and ask about 10 to 15 questions and get the answers to those questions, I could make a field-specific recommendation. I could make an SSNM-based recommendation for any field with the answer to about 10 to 15 questions. That means any farmer could get a different recommendation. But it was too complicated to do this or train people how to do this, so we needed really the power of computing to make that happen. And that started with the Nutrient Manager, with Microsoft Access, and with web-based applications. And then we tried various other approaches, Android applications for smartphones, and an interactive voice recording IVR approach, in which a farmer would call a phone number, there would be a voice recording, asking questions, and the farmer would just push the right number on the keypad to answer the questions. At the end, the text message would come back to the farmer with a recommendation. We then went on to Crop Manager, recognizing that more than just nutrients was needed. It was released in the Philippines, Indonesia, Bangladesh, Vietnam, and in various forms in India, in Odisha, in Bihar, and there are other forms. Through the years, there have probably been 30 or more applications we've developed. Some, they come and go, and these are some of the last ones that we're at now. Now, how is RCM used? It's really about extension workers interacting with farmers. So it starts out by an agricultural extension worker, an AEW, or a technician, or a staff member of the Department of Agriculture, starting first of all with their smartphone, tablet, or personal computer by accessing the internet and downloading an app from the internet. Just a small app that's out there. They then interview the farmer with a series of questions, and they push a submit button that transmits that information that's collected through the internet to the Rice Crop Manager that resides in a cloud-based server. The calculation is done there within a matter of a fraction of a second. We can draw upon databases in the cloud, and it sends back the information that has been transformed into a printed recommendation for the farmer through the agricultural extension worker, and it can also be formed in such a way that RCM automatically generates text messages to the farmer, and that's integrated within the Department of Agriculture for Farmers Contact Center. This is what a recommendation looks like. It has personalized information, name of farmer, information about the farming practices, but a figure that shows graphically for the given variety and management practices what to do at what time. It's dynamic. It's automatically adjusted for the particular farming practices of the farm, whether transplant, direct seed, etc. And the fertilizer recommendation comes out, as I indicated, so much of what source at what time. So there's fertilizer management that comes from SSNM, there's seed rate adjustments with direct seeding, and weeding adjustments with rain-fed rice, no early spray, recommendations for safe alternate wetting and drying, and there's a continual process of updating this with crop protection, with varieties, etc. that's ongoing, but it takes a serious process of verification and putting that science into a format that will, with a high degree of certainty, benefit an individual farmer. Now, there's been a series of trials that have been conducted around the country to look at performance. These are trials over a period of about 3 years throughout the country, averaging of 749 trials here. You can see that the increase in grain yield is about 0.4 tons per hectare on average. And the average income is very close to the target of $100 US per hectare in a crop. Now, how has it performed in the Philippines? In 2012 and 2013, there was the nutrient manager for rice. Let's go to web and an IVR. A nutrient manager is an IVR application. There was also a web application. There was some use. Then the RCM as a web started at the end of 2013. And thanks to the efforts of the Department of Agriculture, about a little over 1 million recommendations have actually reached farmers. All the numbers that I'm going to show have been screened and filtered to take out practice runs. This is not Google Analytics. This is actual recommendations that, to the best of our knowledge, are actually going to farmers. It's not testing, it's not training, they're all screened up. So the RCM is fully supported by the Department of Agriculture. The dissemination is implemented through the DA with local governments, fully funded project by the Philippines. There's about 150,000 farmers that we would estimate in a year to probably give recommendations. Probably about 350,000 go out in a year. There are 2 growing seasons, and the recommendations go out by field. So you can see a farmer is probably getting a recommendation for more than 1 season, perhaps in some cases even more than 1 field. So again, we look across that research to dissemination pathway, and we can see again, hopefully, an actionable, relatively easy-to-use technology that benefits farmers. Here, the local champion with the passion, determination, is Director Edmund Sonic from the National Rice Program. Without his leadership, without his drive, determination, his vision on bringing together organizations and budgets and funding organizations, this would never have even been possible. It even got off the ground. We really owe it to him and to the DA. For us, the IRRI, to think that, wow, this is a feather in our hat. Yes, we help, but they're the ones that were successful. They were successful in integrating this into the extension services. The key is it's not an add-on activity of extension. It is an integral part of what an extension worker does. Not something extra. This is the normal job. It's part of the normal budgets, normal activities. In addition to this, we learned that there's an opportunity with ICT then to also use this as a way to modernize extension services. So, sounds great. Here we have an example in the Philippines. We look at the period from 2014 to 2016, a standard RCM that is deployed through the Department of Agriculture, reaching with 1 million recommendations. Not 1 million farmers, but 1 million recommendations. Maybe 150 to 200,000 farmers have gotten them. Some of them are still getting recommendations throughout the year. There were other projects. There was one project that was a research project that was deploying through research. We filtered that out to assess how many farmers in a period of about 2 years got actual recommendations. And you can see the number is some orders of magnitude less. There was also an application that was developed for a company that has reached about 3,400 recommendations for each department. Moral of it, the lesson of this is that achieving impact requires more than building a good tool. It's the same tool. In fact, the two that have less use are actually more sophisticated in terms of the level of recommendations in the departments. It really takes integration into the executive system. So now there's another component